Our next discussion is about multiple access. There are two types of links: point-to-point with one sender and one receiver, and broadcast links with multiple access. PPP, which stands for point-to-point protocol, and HDLC, high-level data link control, are examples of point-to-point protocols. However, here we want to explore the links with multiple access, with more than one sending and receiving pairs sharing the medium. We want to see how sharing the medium is possible among multiple nodes. In a broadcast link, a sender sends out a frame, and each of the other nodes can receive a copy. You might think of it like a person talking and many other people hearing it. Or a TV broadcast with many receivers. Note that TV broadcast is one-sided, but when people are talking at a party, each of them can talk and each of them can hear. The same is true for the multiple access links. Each node can be a sender and each one of them can be a receiver. Multiple access is used in old-fashioned Ethernet, as well as your 802.11 wireless LAN or Wi-Fi. In multiple access protocols, there is a shared medium and therefore a shared broadcast channel for communication. But similar to the setting of people talking and listening, the senders should decide when to talk and when to listen so that they do not talk on each other. Simultaneous transmission by nodes causes signal interference. If a receiver receives two or more signals at the same time, a collision happens, and therefore the receiver cannot make sense of any of them. This is like listening to many people talking to you at the same time. You might not be able to hear any of them. A multiple access protocol is a protocol that determines how nodes share the channel. The protocol is based on a distributed algorithm. Multiple access protocols, to be efficient, need to contain sharing information within the communication so that they do not need additional exchanges through an out-of-band channel. And they need to do the coordination and control among the talking nodes. The desirable characteristics for a multiple access protocol for a broadcast channel of rate R bits per second is that using it, when one node transmits, it can send at full rate of the channel, which is R. When M nodes transmit, they can each get a fair share of the channel, which is R divided by M. It is fully decentralized, means no special coordination node or no clock synchronization involved. And finally, that the protocol is simple and therefore easy and inexpensive to implement. That is a lot to satisfy. Let's see how we do it in reality. We have three broad classes of multiple access control protocols: channel partitioning, random access, and taking turns. In channel partitioning protocols, we divide the channel into smaller channels. This could be in time slots, frequency bands, special codes, or a combination of them. Each of the divided portions could be assigned to a specific user. In random access, channel is not divided. Everybody uses the same channel, and therefore collisions are possible. What is special about random access protocols is that they can recover from collisions. The third class of protocols are taking turns protocols. In these protocols, nodes take turn in transmission, and the turns could be proportionate to the needs of the nodes and do not need to be limited to specific channel divisions. Let's explore for more details.